morning everyone. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter thermodynamics and today's topic is entropy in thermodynamics. And in entropy, we are solving some PYQ of JEE main. So what is entropy? Entropy is randomness or disorderness of a system. What is that? Randomness or disorderness of a system. Randomness or disorderness of a system. One of the factor, entropy is one of the factor which decides the spontaneity of a process. So entropy decides the spontaneity of a process. It is one of the property, not the complete property, right? So here, what is the question given? In which year it is given? In 2019, the question is given. What is the question? Let us see. The entropy change. They want entropy change. Entropy change. So entropy change is represented by how? Delta S. We have studied that delta S is equal to Q reversible by T. What is Q reversible? Whatever the heat a system is taking during a reversible process. So Q reversible is heat associated or heat absorbed here in a reversible process. Okay. Delta S is given as Q reversible by T. T is at a particular temperature. Whatever the amount of heat a system is absorbing at a particular temperature, that is this T, right? So the entropy change associated with the conversion of 1 kg of ice, there is 1 kg of ice. What is this? There is 1 kg of ice at 273 Kelvin. Temperature is equal to 273 Kelvin. It is converted into water vapors. It is converted to water vapor. So what is this? Water vapors at 383 Kelvin. What is that? At 383 Kelvin, right? So during this conversion of 1 kg of ice into water vapors from 273 Kelvin to 383 Kelvin, what is the change in the entropy? Calculate it. These all values are given. Here generally number of moles will be given, but here you are given kg. Mass is given. Mass of the ice is given. And specific heat, they gave specific heat in kilojoule. Specific heat of water is equal to 4.2 kilojoule per Kelvin per kg. So they did not give in number of moles, they gave in kg, you see, per kg. So already kg of ice is taken and these values are also given per kg. In the same way, specific heat of water vapor is also given per kg. Heat of liquid, heat of fusion of water, that is given as kilojoule per kg. Per kg it is given. Heat of vaporization of water, kilojoule per kg is given. So in this way, all the values are given per kg. At a given mass of the ice is also 1 kg. So let us see here, to convert 1 kg of ice into water vapor, here you are given temperatures. You cannot directly convert it into this, but there are several processes. There are some process involved. First, what happens when you heat 1 kg of ice? What you are doing? When you are heating it, it is converted into, at what temperature it is there? It is present at 273 Kelvin, that is 0 degree centigrade. Right? 1 kg of ice is here. When you heat it, the total heat, whatever you give it to it, it will be used only in the conversion of the state of this ice. All the heat energy, whatever you are giving to this 1 kg of ice, that heat energy is taken by the ice to convert from solid to liquid state. So first process what happens is 1 kg of ice will be converted into water. Whatever the amount of heat energy you are giving, that will be used for the conversion of the state. So now water is at 273 Kelvin, but it is in the form of liquid. This is in the form of liquid, that is water. So whether liquid water has more entropy or solid ice will have more entropy, no doubt about it, because you are giving some heat energy. That heat energy breaks the attractive forces between the water molecules in the ice, so that rigid water molecules in the ice will be free now. There will be more movement in the movement of the water molecule, so that the entropy increases. Entropy increases. So during phase change, your state of the substance is changed. During phase change, we have studied that delta S, we know that it is Q by T. It is happening at constant pressure. It is happening at the constant pressure and reversible. This process is reversible actually. At the same temperature, ice get converted into water. At the same temperature, water get converted into ice. So reversible process. Okay. So this can be taken as Q is equal to, as this is happening at a constant pressure, I can take it as delta H. Delta H fusion. Whatever the heat amount, whatever the heat you are given here, that is considered to be enthalpy of fusion by happening at the temperature. What is the temperature? Fusion temperature. I can take it as F, or freezing temperature. So what is this? Freezing point. Delta H of F is enthalpy of, okay, enthalpy or heat of fusion, whereas TF is freezing point. Freezing point. So now solve it. This is the first step happening. Let us take delta S1 here. So delta S1 is equal to, what is enthalpy of fusion given? Here you see enthalpy of fusion is 334 kilojoule per kg by, what is the freezing point of water? This is all happening at the same temperature called as 273 Kelvin. 273 Kelvin. So if you divide this, What answer do you get? Delta S1 will be equal to 1.22 kilojoule per Kelvin per kilojoule per kg per Kelvin. So we have calculated change in the entropy for the first process. What is that first process? When you start heating ice, it slowly converts from solid state to liquid state. Whatever the heat you are giving to ice, the total heat will be used for conversion from solid to liquid state. Its temperature does not rise until all the ice is converted into water. Right? After converting all the ice into water, next what happens? So now step 2, already we have seen step 1. Now we have water. What is this? We have water. So water at 273 Kelvin. What is this? Water at 273 Kelvin. Now if you still heat it, whatever the heat you are giving, that heat will be used by the water to convert it whatever the heat you are giving to water, that heat will be used to raise the temperature of water. It will be used to raise the temperature of water. So when you are heating it still, then what happens? Slowly the temperature rises, and water get converted into water vapor. What is this? Water vapor. So first its temperature increases from 273 to 283 Kelvin. This temperature increases from 273 to 283 Kelvin. Now still water is in the form of water only. Still in the form of water. Its temperature increases to 383. Temperature increases to how much? 383. So this is the second step. After ice getting converted into water form, then if you still go on heating it, the total the temperature of the water slowly rises and reaches 383. Okay. So whatever the heat you are giving, that heat amount is used to raise the temperature of water. Now here we can use third law of thermodynamics, or let us see. We know that from second law of thermodynamics, ds is equal to dq by T, and here dq is equal to m s dt. S is nothing but specific heat. What is here? S is nothing but specific heat. It is given specific heat. Or you can also take it as C also. It doesn't matter. What the letter you are using doesn't matter. Right? Generally we use S, or if you may be getting confused with as we have S here, entropy, we can also use C. Let us take a C, specific heat. As this is all happening at constant pressure, we can also take it as Cp, mCp delta T. Okay, both sides we have differentiation, we can integrate it. dq is equal to m Cp dt integration. So what do you give? What do you get? Right? Q is equal to integration of mCp dt. Substitute this Q here, right? So ds can be written as, so delta S can be written as here integration of mCp dt by t, right? Instead of dq, what you are writing? Instead of dq, what you are writing? mCp dt, right? Mass already given 1 kg. Mass already given 1 kg. So delta S is equal to, already mass is 1 into Cp into integration of dt by t. Initial temperature to final temperature limits. Then what you get? So delta S is equal to Cp into integration of dx by x gives you log x, t initial to t final limits. Then delta S is equal to Cp into, okay, log t final minus t initial. Okay, log t final minus log t initial. Okay, which log it is? It is not log base 10, it is natural log, right? So if you go with Cp log a minus log b gives you log a by b, log t final minus log t initial gives you log t final by t initial, delta S. If you convert this into log base 10, then what you get? 2.303 Cp log t final by t initial. So this is the entropy change involved when 1 kg of water is heated to 383 Kelvin from 373 Kelvin. So then what is the answer? Delta S2, we are calculating S2, second process S2. So 2.303. So what is Cp given? For liquid water, what is the Cp given? Specific heat of liquid water. Here it is given, you see 4.2 kilojoule per Kelvin per kg. Already the water is 1 kg of water. So mass as it is 1 kg, we are not using the Cp given. What is that Cp? Specific heat 4.2. What is that? It is 4.2 given here, you see. So let us use 4.2 into log T final. What is the final temperature? 373. Initial temperature log 270. So 2.303 into 4.2 into log 373 is given as how much here? Already given 373, 2.572. 2.572 minus of, what is log 273 given? 2.436. What is that? 2.436. So as you are heating it, delta S, you will get it as how much? Positive value, because when you are heating, the change in entropy will be positive. What is that? Change in the entropy will be positive. So delta S2, how much you got? 1.31. Next, coming to now third step. What is that? Third step. Now we are having water at what temperature? Here is water at what temperature? 373 Kelvin. What is that? 370. Now you are heating it. When you are heating it, this 373 Kelvin is the boiling point of water. What is that? Boiling point of water. So when water at 373 Kelvin is heated, whatever the heat you supply to it, the total heat will be used to convert it from liquid state to vapor state. What is that? Liquid state to vapor. So what is this? Water vapor. So whatever the heat you are supplying, Q you are supplying to this, that Q will be used to convert the water from liquid state to vapor state at the same temperature, 373 Kelvin. So what is this 373 Kelvin? Boiling point of water. What is that? Boiling point of water. Again, we are speaking about here phase change or state change. What is this? Phase change. During the phase change, here what is happening? Liquid water is converting into vapor. So delta S vapor. Entropy change during vaporization. Entropy change during vaporization is V Q reversible by T, which Q, this is all happening at constant pressure, then delta H. Okay, so vaporization by what you write? TB. What is delta HV? Enthalpy of vaporization. What is that? Enthalpy of vaporization. What is TB? Boiling point of boiling point. Okay. Now you see delta S. This step is third step or the third process, that is equal to. What is enthalpy of vaporization given to us in the question? Enthalpy of vaporization given is or heat of vaporization or enthalpy of vaporization is 2491 kilojoule per Kelvin. That is how much? 2491 kilojoule, okay, per kg by what is the boiling point of water? 373 Kelvin. So if you substitute this, what answer do we get? So we get is 6.67 kilojoule per Kelvin per kg. But the question asked is, it has to be converted to what temperature? Not 373. It has to be converted to 383 Kelvin. Now you are heating 1 kg of ice. It has converted into water at 273. Again you are heating it. It is converted into 283 Kelvin water. Again you heated it. It converted from liquid water to vapor at 373. But you need to increase its temperature up to 383 Kelvin, right? So fourth step. What is that? Fourth step. In the fourth step, what you need to do? Here you are having vapors. What is that? What is that? You are having vapors, water vapors. Now you are supplying some heat so that vapors, here also we have water vapors only, water vapor, but here the temperature is 373, but here the temperature The temperature has been increased from 373 to 383 Kelvin. Okay. So this is all happening at constant pressure. Again, we can use the formula. What is that? Delta S is equal to integration of m Cp dt by T. Before we have derived, right? So delta S, T initial is 373 Kelvin, T final is 383 Kelvin. And already we know that mass is 1 kg, 1 into Cp integration of dt by T. That is equal to Cp into log 383 by 373, right? Then what do you get? Delta S. So delta S is equal to 2.303 into Cp into log 383 minus log 373. That is equal to 2.303. What is Cp given? See, let us see. Cp given for vaporization, heat of vaporization. Cp for water vapor. We are speaking about water vapor. Specific heat of water vapor is how much? 2.0. What is that? Using 2.0, right? Into 2.0 log 383 minus log 373. So in the question already given, right? What is log 383? 2.538. What is that? 2.538. So already data is all given. 2.538 minus 2.583, 2.572, 2.572, 2.57. So if you solve this, what answer do we get? We get it as 0.05. 0.05. So this is delta S4. So the total entropy change, what is that? Total entropy change for water at 0 degree centigrade, that is 273 Kelvin, to vapor, water vapor at 383 Kelvin. The total entropy change will be equal to delta S total is equal to delta S1 plus delta S2 plus delta S3 plus delta S4. Okay. Delta S4 already we have seen here 0.05 plus delta S3 we have calculated it as how much? Delta S3 is 6.67, right? 6.67 plus delta S2, how much did we get? 1.31. Delta S1, how much did we get? 1.22, 1.22, 1.31, 1.22, 1.31. So totally if you calculate this, you'll get 9.26 kilojoule per kg per Kelvin. Okay, so we are given 4 options. Let us see that. So we have 4th option, 9.26 kilojoule per Kelvin per kg. Okay, so this is how we need to solve such question. Based on this concept, one more question is given. in very much recent examination, and that is in 2025. Let us see that question. So in this way, see 2025, the question is given. Ice at minus 5 degrees centigrade. Ice at minus 5 degrees centigrade. So we are having ice here, ice minus 5 degrees centigrade. Minus 5 degrees centigrade means if you convert it into Kelvin, how much do we get? 273 minus 5. Then what do you get? 268 Kelvin. So ice is at 268 Kelvin. Is heated to become vapor with a temperature of 110 degrees centigrade. So it is to be heated to water vapor at how much? 110 degrees centigrade. 110 degrees centigrade will be equal to 273. Add it. Then what you get? 383 Kelvin. 383 Kelvin at atmospheric pressure, at the same atmospheric pressure, at constant pressure. The entropy change associated with this process can be obtained from how much ice they did not mention. How much ice they did not mention. So let us see. First, will it directly convert from ice to vapor? There are some steps involved here. What is that? There are some steps involved. So what are those steps? Let us see. First of all, what has to happen? Ice, here is ice at plus 268 Kelvin. If you heat ice at 268 Kelvin, heat it, what happens first of all? What happens? What happens is ice will be remained as ice up to what temperature? Up to its fusion point or melting point. What is that called as? 273 Kelvin ice. So whatever the heat you are supplying to it, it will be used to increase the temperature from 268 Kelvin to 273 Kelvin. So when there is change in the temperature, in before question we have already studied, when there is change in the temperature, then delta S will be equal to integration of initial temperature is 268 Kelvin, final temperature is 273 Kelvin. Then so number of moles or whatever the substance, the amount of the substance is not mentioned. So if you take 1 mole, in the question already, in the options you can find M. What does this M represent? M represents molar. What does this M represents? Molar. That means when it is calculated molar, when you are speaking about molar, then the substance will be 1 mole. So you can use N also, but in the options we don't find N. See here in the options we are not finding N. So simply we can go with or directly you can use NCP, okay, dt by T. Before also we have discussed this. So as number of moles, when it is calculated here M, if you write M, then it will be for 1 mole. Here number of moles are not given. Considering that it is 1 mole, then you can remove this, right, based on the options. Okay, so this will be 1, delta S1, entropy change first. Then now let us go with the second step. In the second step, what happens? There is ice at 273. Now you are supplying some heat. Whatever the heat you are supplying, that will be used to convert it from ice into, okay, water. Because 273 Kelvin is melting point. So what happens? Fusion occurs or melting occurs. Whatever the heat amount you are supplying to it, that will be used to convert ice which is in solid state into water in liquid state. Now water is also at 273 Kelvin. There is no change in the temperature. So then how can you delta S fusion you can take? So then what will be this? Delta H fusion by TF. TF is freezing point. Right? Whatever the heat amount you are supplying at that freezing point, that gives the change in the entropy during the fusion. So let it take it as a delta S2, that is equal to delta HF by TF. The third step is water at 273 Kelvin. Now again you are heating it. When you heat it, now water is converted into again liquid water, and whatever the heat energy you are supplying to it, that heat energy is used to raise the temperature of water from 273 Kelvin to 373 Kelvin. Up to 373 Kelvin, this water remains as water here, liquid state. When you are going on heating this water at 273, you will find that the temperature of the water slowly increases up to 373 Kelvin. So now there is change in the temperature. Then delta S3 can be calculated as initial temperature is 273 Kelvin, final temperature is 373 Kelvin. Number of moles for 1 mole we are considering, then we can write Cp molar into dt by T. Okay, dt by T. So this is the formula to find the change in the entropy. Find change in the entropy during this change, water heating from 273 Kelvin to 373 Kelvin. Next, now water is at 373 Kelvin. Now when you are heating it still, whatever the heat you are supplying it, that will be used to change water into water vapor. Change of state. So this water is at 373 Kelvin. Now water vapor will be also up 373 Kelvin. Until all the water in liquid state at 373 Kelvin is converted to water vapor at 373 Kelvin, there will be no change in the temperature. So in this fourth step, what is happening? There is change of state. So during change of state, what we have written? Delta H. What is happening here? Water is vaporized. So delta H vaporization by TB we write. What is the TB? Boiling point. At boiling point, what is the boiling point? 373. See, here is also to 373. Here water in liquid state is at 373. Water vapor is also at 373. Right? So whatever the heat supplied to the water, that is change in the enthalpy by at that particular boiling point gives you change in the entropy. Okay. Next, fifth step. In the fifth step, what happens? Now we are having water vapor at what temperature? 373 Kelvin. Now you are supplying heat energy. Whatever the heat energy you are supplying to it, it will be used to raise the temperature of water vapor. You are supplying heat energy until its temperature rises to 383 Kelvin. 373 Kelvin to 383 Kelvin. So we are asked in the question, about what? Heating ice at minus 5 degrees centigrade to water vapor at 383 Kelvin. So delta S 5, fifth process. Here change in temperature is happening at constant pressure and there is no change of state. Then what is the formula? T initial is 373 Kelvin, T final is 383 Kelvin. Number of moles considering molar. So molar heat capacity into dt by T. So 5 steps are involved here. Now delta S total will be delta S1 plus delta S2 plus delta S3 plus delta S4 plus delta S5. So all these you need to add. So when you add all these, where you are finding options? First Cp dt by T. See in the third option you see 268 Kelvin to 373 Kelvin, Cp molar dt by T. Next second, here you are having H, delta H fusion, for M represents molar. Okay, fusion by Tf. Do we have that? Next, see delta S fusion is equal to delta H fusion by Tf. Next is all you are adding vaporization by Tb. Do we have vaporization by Tb? Yes, delta H vaporization by Tb. Next CPM dt by dt from 273 to 373. Yes, we are having 273 to 373. This one. Next 373, 383 CPM dt by T. Last one is that 373 to 383 CPM dt by dt. So what is the answer? Third option will be the correct answer. First option also seems to be similar, but what is missing there is by dt is missing, by T is missing, by T is missing. There is no T here, right? Regarding the change of state, regarding the change of temperature, this type of question is asked. Hope so everyone understood. We shall meet in the